Let's assume that I have a file in HDFS. The file name is sample.txt, and that is there in HDFS, and block size is 256 MB. Sorry, the file size is 256 MB, and my block size is 64 MB. So I will get 4 blocks. Let's see this. Block 1, block 2, block 3, and block 4. This is how the data will load. This is how the data, I'm not showing you data node and all. I'm showing you a little high level, where your HDFS, this is the data. It will be there in a blocks. Block 1, block 2, block 3, and block 4. Correct, guys? This is how the data will be there in HDFS. Yes or no? So the data will load into different machines. The data will divide into blocks, and the data will be loaded into different machines. Correct? So whatever the data is loaded into different machines, how to process the data? How to process the data? We have seen till today how to load the data into HDFS, and internally how it works. What is the block, and how the blocks get divided, how the machine will get allocated. So what is the rack awareness? So all these things we have seen till today. Correct? So now we have completed the storage part. Now we are going to see how to process the data. How to process the data. This part is for storing. This part is for storing. Now we are going to see process. Process the data. What are the data you have loaded into Hive, loaded into HDFS? So we are going to see that how to process that data, right? How to process the data? The Hadoop is given a component called Mapreduce, right? So the HDFS is for storing the data, and the Mapreduce is for the processing the data. Mapreduce. What is a Mapreduce? Mapreduce is a programming model. Mapreduce is the programming model, or you can say design pattern, or you can say framework, which will process the huge amount of the data, parallelly. Huge amount of the data means the data is there in HDFS. So to process the data parallelly, the data has to be there in DFS, distributed file system. That is HDFS here. Right? So what is a Mapreduce? Mapreduce is a programming paradigm, or you can say programming model, which will process the huge amount of the data in parallel fashion. Mapreduce is a framework, or Mapreduce is a programming model, which will process the huge amount of the data in HDFS as parallelly, or parallel fashion, right? What does it mean? The data, what are the data I have loaded into HDFS, that data will be processed parallelly, independent tasks. How it will happen? So in HDFS we have seen something called master slave architecture. Master is there, name node, and the slave is there, data nodes. Master is name node and slaves are data nodes, right? In the same way, your Mapreduce also follows something called master slave architecture. It's also follows master slave architecture. Here your master is name node, which is a physical machine. And data node also same. And also guys, you also have something called name node service and data node service. That is what we are seeing here. Those are not only physical machines. That is what you are saying. When you say JPS, when you type JPS, you are saying name node service, data node service, secondary name node service. So these are all service. Those are physical machines, and those are all having a service, right? Here when it comes to Mapreduce process, we have something called master We have something called master, which is a job tracker, which is something called job tracker, and which is a daemon service. As like your name node service, daemon data node service, secondary name node service, right? There is something called job tracker test service. So guys, here I'm introducing Hadoop 1 architecture, because first we need to understand what is the Hadoop 1. Then once you understand Hadoop 1, I will take you to Yarn. Whatever we are using is Yarn in our setup. Code never changes. The code is same. Whatever the code we are going to write using Mapreduce, the code will not change. The code is same. The only change is architecture. The only change is architecture. I will show you what is architecture changes. So in the Hadoop one, there was a little bottlenecks. So there were some bottlenecks. So how the bottlenecks are been overcome in Hadoop 2. So we are going to see that in the next, once you understand the Hadoop 1 first. Okay, I'm explaining here job tracker, task tracker, which are daemons of Hadoop 1 service, Hadoop 1 version. So first try to understand what is a job tracker, task tracker. Then I will show you resource manager, your application master, your application manager, your node manager, containers, everything I'll explain in the later part. First we need to understand the basics thing, then we can go with advanced. Now here the master service is job tracker, and the slave service is task tracker. One is master service, another one is slave service. So most of the cases your master service will be running on the name node. If you guys remember, I have shown in the architecture sometime before, in the name node, in the one of the places of task tracker is running, and wherever the data node is there, and all the data nodes, your task tracker will be running. All task trackers will be running in that, correct? So can't we have a separate job tracker? Yes, we can have a separate job tracker. In the most of the production environment, we will keep a job tracker or resource manager, whatever you will call here. So let me differentiate. So whatever you will call here, resource manager, task tracker or node manager. These are Hadoop 2, these are Hadoop 1. Okay, so why resource manager, node manager, why can't it be job tracker, task tracker? We will talk very detailedly what is the difference between them. Right, so this job tracker or resource manager can be in a different machine, but your task tracker and node manager cannot be in the different machine apart from your data node. Your task tracker and node manager has to be there in the same data nodes to achieve the data locality. What is that? Let's look at the high architecture, guys. This is our name node, and here I'm taking very small data nodes. Okay, data node, data node here. So I'm not taking client and all those things. Okay, so normally wherever your job tracker is, wherever your data node is running, there only the task trackers will be running. It has to run there only. Task tracker will be running here, task tracker will be running here. Why? Because the data will be there in these machines only, no? But your job tracker can be in the same machine, or it can be a separate machine only which is running in the task job tracker. It can be, or it can be separate machine. Why? Because the process will happen here. Your job tracker daemons will do a process. If the job tracker daemon is a separate machine, here let's assume that my task tracker is here, my data is here. When I launch a job, it has to copy the data to this. It has to copy the data to this, which is wrong. We are missing data locality. Copying data from one hard disk to another hard disk is really tough job. It's a time consuming process. So we don't like that, right? That is the reason wherever task trackers are, data nodes are running in the same machine only, your task tracker will be there by default. I mean, you have to start the service. But your job tracker can be a different machine because there is no dependency on your job tracker with a name node, right? When anyone submit a job, anyway we will see detailedly. I'm just giving an idea. So when anyone submit a job, whether with respect to this machine or other machine, the request will go to job tracker because it is a job. How to map it is job. So your job should contain what is input file, which data I need to process, So your job tracker will communicate with the name node to get the locations of that blocks wherever the data is located. Then your job tracker asks to perform task on the task trackers, right? If it is separate machine, it will ask from the separately, nothing else. If a separate machine, it will ask from the other machine. So there won't be any huge dependency on the name node. So what, when you submit a job, let's assume that you have submitted a job from here. Let's assume that you have submitted a job from other here. So what this guy will do, he will create a job ID for the job and he will go and talk to the name node giving, sir, I want to process this data. This data is, tell me where and all the data is located. And your name node will respond with the your metadata information to job tracker. Then job tracker decide to launch wherever the data is there. Is everyone able to follow till here? Any doubts till here? If you understand this thing, I'll take you to further. Any doubt till here? Akash, Anisha, Ganesh, Harika, others?
Oh, Veera.
Is this clear?
Yes.
I'm hearing only one voice. Guys, this is really important. You want how to understand the basics. Once you understand the basics, we can go and build out advanced things. Akash, okay, okay, yeah, good. There's some chat messages. Let me see that. Okay, everyone is good. It's nice to hear. So everyone is clear till here. Now, now. So now let's see your your architecture of Mapreduce. Same architecture only, but I'm going to put specifically the specific to this. Okay, we have one job tracker. This is your job tracker. This is your task tracker. This is your task tracker. This is your job tracker, and these are all your task trackers, right? So when the job is submitted to this guy, when the job is submitted to this guy, and this guy will, the job should have an input path and output path on which data I need to process. So we're taking that input path and it will go and talk to a name node and get the locations of the data and it will launch the job. We will see in detail about that. Okay, now that's internally happens. So then what is the map reduce? What is the map reduce? What is a MapReduce? See guys, this MapReduce is a programming model, or I can say it's a framework where you have a two phases. Actually, there are multiple phases, but time being, let's understand only two phases. Okay, the first phase is mapper phase. Mapper phase. First phase is mapper phase. What this mapper phase will do? What this mapper phase will do? It will map your logic, your map logic with single block. It will map your map logic with the single block. So what does it mean, sir? Let's look at guys here. This is your HDFS path, and you have a blocks in this. Let me take 4 blocks as similar as above example. Block 1, block 2, block 3, block 4. Now you have written some logic to process this data. You have written some logic to process this data. Your whole logic to process this data, we will divide into two phases. We will divide into two phases. The first phase is map phase, second phase is reduce phase. Why we need to divide into multiple phases? Because try to concentrate guys, because the data is there in the multiple machines, distributed machines. The data is there in multiple machines, here, 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 here. So the first phase, what it will do, it will take the data, it will do a basic operation. It will do a basic operation. So the whole logic, right? Let's say you want to find some maximum salary on employee table. Let's say you want to find maximum salary of an employee. That's your requirement. Okay, so you have loaded your employee data. Let me write the employee table here. This is my employee table. This is my employee data. Let's assume that who has only 3 columns. Okay, I'm going to take only 3 columns. Who has only 3 columns. The first column represents ID. The second column represents name and salary. The first column is ID, name, salary. This file size is this employee file. So I'm taking simple example, guys. I'm taking simple example. So this employee, size of this employee is 256 MB. So how many blocks will be divided? 4 blocks. Do you guys agree with me? 1, employee 1 or 1000. Employee 10 V 750. 11 SV 2000 and 2 Vera 3000 and some 3 something else 4 7 SVR 10,000. Now the whole data has been in the data. Now this file will be loaded into HDFS. As soon as you load into this file into HDFS, how many blocks will be divided, guys? How many blocks will be divided? 4 blocks. Correct, because 256 MB and my block size is 64 MB. Yes or no? Let's assume that I am dividing this into block 1 and this is block 2, and let's assume that I have some more here, block 3. Okay, block 1, block 2, block 3, and I have something called block 4. So this data is divided and put into HDFS, correct? So this is the block 1 here, this is the block 1 here, this is the block 3 here, this is the block 4 here. Now in this, when I'm processing the data into this data, because I'll be processing only block of data only, right? It is not like a whole data process single attempt, correct? So it is processing parallelly, right? While I'm processing this 3 records, what is my maximum salary? 2000. And when I'm processing this, let's say here 2500, when I'm processing this data, the 3000 is the maximum. When I'm processing this data, 10,000 is the maximum. And when I'm processing other block, maybe 5,000 is the maximum. So what is the actual maximum? What is my requirement? I need the maximum salary. When you say maximum salary, only one guy will be there, 10 people will be there. Guys, are you guys able to understand what I'm trying to say? Anisha, Ganesh, I have an employee table. I have employee table which has so many records. In that I want to find the maximum salary. How many records will come for the maximum salary?
One record.
Only one record will come, right? When you put that employee data into HDFS, it will break into pieces. It will break into pieces. When you break into pieces, there will be multiple pieces. And your logic will be running on your whatever the logic you have written to find the maximum salary, that logic will be working on the piece by piece, right? Yes or no? The logic will be running on piece by piece. Uh, could you please respond, guys? I want someone who can interact with me. Anisha,
Yes,
correct? So the data will be broken into multiple pieces. Whatever the logic you have written, the logic will be running parallelly. So your logic for the maximum running here. Max logic will be running here. Max logic will be running here. Max logic will be running here. Here. It means your logic is running on the piece by piece. I mean all the blocks parallelly. Correct? Yes or no, guys? So it means when it's running with a piece of data, this piece of data maximum salary is 2000, other piece of data maximum salary is 3000, other piece of data maximum salary 10,000, other piece is 5,000. Now, but actual, I need a final result as a single, right? If you give these 4 parts, so I cannot understand this. Being a business user or business client, do you guys understand the problem, Anisha?
yes,
So
Yes, Veera.
if I launch a whole logic, if I launch a whole logic or MapReduce as a single phase, not the multiple phases. If I launch a whole logic as a MapReduce in the single phase, what will happen? The whole logic will be executed here and other block, other block, other block. Then I will be getting 4 different results. This piece of data will telling 2000. This piece of data is telling 3000. This piece of data is telling 10,000, and this piece of data is telling 5,000. So which is not accurate. It has to be club again. There should be another thing who can say, who can calculate all this and who can say, oh, 10,000 is the maximum salary. Someone has to tell like that, correct? So what MapReduce framework is did, the MapReduce framework comes into 2 phases. The MapReduce framework comes into 2 phases. So one is the map phase, other one is reduce phase. What map phase will do, what is map phase will do, it will identify, like, it will first the basic logic, we will write the basic logic which will map with each block, which will map with each block, it will map with each block, and he will start doing a basic operation like finding a max. In a single function we can find the max, there is no problem in it, right? So the map will map with a single block of data. Here I'm not really showing internals of it, we will be showing you some more internals. So one you need to understand. So first I'm showing you very high level, then I'll take you a little deeper. So this map will give the results like this, 2000. So output, your map output, here our map output comes 2000, here your map output comes 3000, here this map output comes 10,000, here your map output comes 5,000. So there should be some more guy who can find again a max on all this. That guy is called reducer. So what will happen here? What will happen here? All your map output will be taken from here, and all the results will be clubbed here, and there will be some called reducer. What this reduce guy will do? It will reduce, and he will also apply his logic on mapper outputs. Your reducer will work on the mapper output. Your reducer will work on the mapper output, and other phase is reduce phase. That reduce phase, what will do? It will collect all your mapper outputs. It will collect all your mapper outputs. Then it will produce a final output. It produces a final output. Okay, there are two phases. One is the map phase, another one is reduce phase. What map phase will do? It will map a piece of logic with each block, and it will start processing, and it will start giving you output. It is parallel, it is happening parallelly. So all the blocks will be mapped with your map logic, and all mappers will give some output, and that output will be given to a reducer, and reducer will give final output. This is how the process will happen very high level. Guys, still there are so many. When you go little deeper, you need to understand short and shuffle, you need to understand copy paste, and before that you need to understand input format, input split, record reader. There are so many things, we will see them. If I bring them everything in a single shot, you will get confused. That's why I'm showing you first mapper and reduce phase. Then before mapper what will happen, after mapper what will happen, I will show you that, no, one after one, right? So what is a map phase? Your mapper is nothing but a Java object. Your mapper is nothing but a Java object, a Java instance, mapper instance. The mapper instance who will work on a piece of data, who will work on the piece of data like this. In this piece of data, your mapper object will be launched. In that mapper object, you have something. In this mapper object, you have something. In this mapper object, you have something called. This is mapper object, no, Java object. It has something called setup method. Not to worry about the setup method. It's very simple. And the important one is map method. And there is something called cleanup method. As I said, mapper is a Java instance. In the Java instance means Java object. Inside the Java object, you can have a methods, right? We have seen. So in the mapper class, you have some methods. That methods are there. So here, our main logic will go into this method, map method. Okay. The same way, your reducer also has the same set of methods. Setup method, reduce method, and a cleanup method. So what are the logic? You are finding a minimum or maximum. What are the logic? That logic will be written into this guy map, and here the reduced logic will be writing into. So we will be more concentrating on this map method and reduce method. We'll be more concentrating into map method and reduce method. So is everyone is clear till this part? Is everyone is clear till this part?
Yes, sir. Veera,
Yeah.
actually this mapper and reduce I mean, is it associated with job tracker or with both job tracker and task tracker?
Very good. Job tracker is a daemon service who accepts the job. Okay. Who takes the job. Now this mapper and reducer is the way to write a job. First you need to write a job. First you need to write a code, right? This
Okay.
the mapper and reducer is the, you will write the code in it. Job tracker is where you launch, like who takes the job. To create a job we need these
Oh,
two
okay.
classes. Okay, like let me tell
Okay.
you. So let's say you want to add two numbers. First, what you'll do, you'll create a class and you will create a main method. In the main method, you'll call a add method. Then before that, you will write a add method and you'll call that add method. Correct? First, you will create a class. Then you will create a add method. Then you will create a map main method. From the main method, that add method will create. Right? So
Correct.
that code, whatever you have created class, main method, app method, that code is nothing but your mapper and reducer classes. Mapper class, reducer class, mapper phase, reducer phase. Coming to job tracker, job tracker task trackers are the environment or the people who process that your code, who execute your code, like a JVMs. Okay, job tracker will not execute your code. Keep in mind that as similar as your name node will not store any actual data. So the same way, your job tracker will just take the job, assign to the job, it will find the resources. There are so many other tasks for the job tracker. Job tracker takes the request, create a job ID, and it will identify the where and all the data is available, and assign the job to the task trackers, and it will be keep monitoring it. Is there any job is failed or job is running properly or not? It will be keep monitoring it. Okay, that is the role of a job tracker. The actual task, who is going to execute your map, who is going to execute your map, who is going to execute your reducer, the task trackers. So you will write a logic using Java in this mapper and reducer that will be executed in the task tracker and task trackers and job tracker take to accept the job, task tracker is to execute the job. Clear, Anita? Am I answered your question?
Yes, Veera. Thank you.
So the job comes from the client node to the name node, then name node assigns the job to job tracker, then job tracker assigns to task tracker.
Correct.
So after processing from task tracker, where does this go?
After
After processing in task tracker,
mhm,
where the job goes?
the final output you're talking about, intermediate output.
Yeah, final output,
The final output will go to HDFS only.
HDFS.
That is the ideally you want to put the final output, right?
Yes.
So you will take the input from HDFS and you'll keep the output in HDFS. Or what you can do, you can also keep the output into some other databases like NoSQL database, or you can keep in a HBase, or you can keep in a Redshift. You can keep that. Not only HDFS, you can also keep it in a, initially it will write into HDFS. After from there it will take
Yeah.
and you can run one more job too who can take the output from the HDFS and keep it in a other databases. That can be done. Is everyone is understood high level understanding of your MapReduce? Everyone understand this?
Ravi, I have a doubt.
Go ahead, Ganesh.
Yeah, yeah. If something happens in reducer code,
Okay.
or if something okay, something in reducer code, so
Mhm.
will the job tracker will be able to differentiate that that issue is there in the mapper code or reducer code like that?
It will. You can also see the job will fail. First, sure, the job is fail. Okay, job will not complete, job will not success. Job will fail. Okay, and you will not get any output.
Okay.
You will not get any output. But what it will do, it has been failed in this phase. It will print the logs. You can see the log where it has failed, which logic is failed. You can see that.
Okay. But initially while loading, we will be loading the mapper and reducer code initially if it's fully correct. So
See,
after that, the job tracker, it will split the jobs like something like that.
correct. Initially, whatever you write your job mapper code, reduce code, ideally those are different class files, or you can keep in a single class file also. That we will talk more. So ideally, what we will do, you will write your mapper code, reduce code. You will write in a single shot, and you will create a jar file. Why we need to create a jar
Okay.
file? Because the whole, not only here, even in the normal applications also, after finishing your project, let me show you guys here. That will little make you understand. So I have written some code here. Let's say I have written some code for something, some, let me show you. These many programs we are going to do. Let's assume that I have written some program, word count program. So this is my driver code, and don't get confused. Okay, don't look at the code. I can say, if you look at the code, don't get confused at all. So I will detail explain each and everything. Okay, till I explain, don't get confused. So because he brought the question, so I want to show him how it will be. So normally what we will do, we will be having one driver class, okay, who has the main method, okay, and we will be having some mapper class for the map phase. So we have to be always separate file. You can, in the real time, will always will be separate file for mapper phase, because to load, to differentiate, and easy to debug, easy to find. Okay, you will be having map method, you will be writing your logic in this. Okay, and you will be having reduce and reducer, so that will be a separate file. Okay, and these two files will be referring here, the two files will be referring from here. Okay, now using these three files we will create a jar file. How we will create a jar file, I'll show you. Okay, don't worry. So we'll create a jar file. We will create a jar file like this. We will create a jar file like this. If you go and see internally, internal of this jar file, it's not able to open here. So if you see inside of this jar file, you will be having three files, three dot class files, not the Java files. It will compile and it will create. Okay, let me show you here.
So the jar file contains all the three mapper code, reducer code, and the logic.
Code means dot class files, not dot Java files, right?
Okay.
So let's see here. This is jar, right? This is a jar. Okay. Inside the jar, look at
Yeah.
here.
Yeah.
Let's say I'm going to take one class from what which is the class will be frequently using IO package, right? Okay, let's take some package from here. Okay, not a problem. So no need to see. Let's say I want to see some, this one. What is this dot class file, right?
Okay.
The jar contains
Okay.
dot class files. The same way, what are the jar you have created here? No, it also contains all these three classes. Okay, then this file we
Okay.
will give to your job tracker. Actually, we will give in the sense we will launch a job using this jar file. So then your job tracker
Okay.
takes this jar. Actually, it will not take the jar, guys. Okay, this will be there in one location. We'll keep in one location. Then your job tracker takes the request from the client saying that, okay, I need to process this. Fine. So give me what are the classes I need to process and give me input of it and where to put the output. You have to tell that. So your job tracker will take the request and it will create a job ID and it will identify the locations and it will launch the job. So that is how the real time will happen. The job tracker responsibility is take the job, create a job request ID, a job ID, and schedule the job and find the resources where to launch a job. Find the resources where to launch the job and launch the job. And after launching the job, monitor the job. So these many responsibilities done by your job tracker. Taking request, scheduling it, identifying the resources, launching the job, monitoring the progress, all these tasks will be done by your job tracker. Okay, so this task tracker, right, while it is in a map phase, it will be processing, it will be first map phase, then only reduce phase. That is the way it will work. The framework works, first it will execute the map, then it will execute the reducer. There is no chance first reducer execute later map. No, there is no chance at all. Why? Because the framework is designed like that. The reducer will always looking for the output of the mapper. The reducer is always looking for the output of the mapper. Look at here, this 2000, this 3000, what is this? It's output of your mapper. Your reducer always work on output of your mapper, output on your mapper. It will not work before executing your map. Okay, so the framework is designed such a way that first map phase will work at any cost. It means what are the map code you have written here, no, in the I have shown mapper class, that code will execute first. It will create the output. That output will go to data nodes local memory. Keep in mind this, anyway we'll be discussing it. So the mapper output will go into your data nodes memory. Then memory means your hard disk, local hard disk. Then your reducer collect all the output of mappers. Then again it will launch your reducer job. You have to write both the logics. Is everyone is understand? Any confusions? New guys who are not from Java background? Harika, Kishore, Rakesh, Sai, Nikesh and others? Any confusion?
No, no, till now, no.
Okay. Ganesh, you?
Yeah, Ravi, so if the data's it doesn't initialize the data nodes for it doesn't find the data nodes, right, for the processing.
No,
Like
it will
for
find
given the data node locations, don't know what I'm asking is in the code we have to write the data nodes are there
no.
like that, or it is internally doing on its own.
It will internally find that. We will not define,
Okay.
we will not define data node locations. We will not define the data location. We will tell that in HDFS the data is there here. That's it. Your job tracker will go and talk to a name node to get the locations of blocks.
Okay. Thank you. Yeah.
Any doubt, Harika?
No, sir.
Please, guys, if you didn't
Data node
understand.
does that. Data node does that internally. We are just specifying the HDFS path while we execute the jar file.
Data node does internally. What does it mean, Masood?
No, while executing the jar file, we will specify the input path or output path, right?
Correct.
So we'll give the locations of HDFS.
Name node will give the locations of the HD. See, this is our file, no? Training one data sample. We will, while giving your job, you will give this location along with the jar. You will give jar space and class name space this input, this file path you will give.
Yes.
Your job tracker will take this request. After taking your request, it will go and ask name node. Hey, they're asking me to process the sample data. The client is asking me to process sample data. Give me where and all the blocks are there. And your name node has a metadata information. Name node will respond to the job tracker with the locations information, and job tracker will launch the job in the task trackers. Any doubt, Masood?
No.
Yeah. Any other? Anyone else? Anyone else?
Will there be any like signals will be received by this job tracker, like whether it is completed,
Yeah, they will be getting.
like that, Ravi?
Yes, they will be cutting.
Okay.
Your task trackers will be. They'll be giving the progress. So your job tracker will be keep monitoring the progress. What is the progress of the task tracker 1? What is the progress of the task tracker 2? What is the progress of the task tracker 3? It will be monitoring.
Okay.
Veera, so if you want to process it, we'll give the jar file name like .jar and then the HDFS path.
Yeah.
That's it, right?
Yeah. So let me show you the command, guys. So how we will give the command? Let me show you. I'll type it here. Okay. Let me write in the
Output path then?
output path.
Output path also will.
Yes, you have to specify the output path. Otherwise, how it will know where to put the thing? Look at, guys, here I'm writing the command, but it's very early to show that. But still, the people are raised to understand the things. Yes, I'm going to show you. Let me, my cursor is here. Let me put my cursor is here. Okay. So the command is Hadoop jar path of the jar, where your jar file is there. Path of jar, where your jar file is there. Okay. And class name, fully qualified class name. Let's say my class name is there in com dot vira dot mr dot word count. Let's assume that this is my class name. Driver class name space input path slash training 1 slash data slash sample dot txt. This is my input, and I want the output in slash training 1 slash output. This output no need to exist, should not exist. Okay. Output, the output should not exist. The output directory should not exist. What are the directory you are specifying, or inside the output you are specifying, let's say wc, the wc should not exist. Okay. As soon as you execute this command, this much big the command is. Hadoop jar path, and the class name, what class you are going to execute, driver class name, and what is the input to your job, and where to put the output of your results, final result, not the intermediate result, final result, where to keep the final result. So you will specify this much. As soon as you specify this much, what will happen, your job tracker will take the request. And after taking the request, it will create a job ID, and it should know where this data is there, right? Yes or no? It should know where this data is there, and taking this information, and it will go to the name node. Taking that information, it will go to the name node. So they're asking me to process sample data, where is the locations, and your name node will respond with the location addresses and IP address and block the metadata information ideally. So now your job tracker knows that everywhere his slaves are there in the data nodes. Then he will ask to the slaves, you go ahead and process this block, you go ahead and process this block, you go ahead and process this block. Like that, your job tracker will assign the work to task trackers. Then task tracker will start processing the data. While it is processing, your job tracker will be monitoring it. If anything is failed, it will relaunch. We will see all those things, how it will relaunch, and how speculative execution and all we'll see. Clear your doubts, Anisha?
Yes, Veera. Thank you. I got
Masood?
it.
Masood, your doubt?
Yeah, I'm fine.
Rakesh, Sai, Nikesh, Harika, others. I hope everyone is clear about this, right? Tomorrow we will be seeing detail about what is the mapper phase contains, what is the reducer phase contains. We'll be seeing a very detailed tomorrow. Don't miss the classes, initial classes. I personally requesting you guys, don't miss the initial classes. If you miss the initial classes, you will be missing the flow. Okay. Thank you.